Alright, today we're going to talk about the law of sines. This is used to solve non-right triangles, also known as oblique triangles. So let's talk about what the law of sines is. So the law of sines, it will require a triangle. We will call the angles A, B, and C with capital letters. The sides are the labels from across the triangle. So capital B is across from side lowercase b. Angle A is across from side A. Angle C is across from side C. And the law of sines is that the sine of angle A over side A is equal to the sine of angle B over side B, which is also equal to the sine of angle C over side C. So let's look at how that works out. We start our problem off by labeling what we know. Well, I know side A. I'm missing side B. I'm missing side C and angle C. I like to give myself a little space off to the side somewhere to label what I need to find. I need angle C, which you can just use a capital C for. I need side B, and I need side C. Now, anytime you only have to find one angle, it's actually quite straightforward because the angles of a triangle always add up to 180. So if I take away from 180 my 36 and my 48, I will get my angle C. If I could type things right in my calculator. All right, angle C is 97 degrees. Now we set up that big old nasty looking proportion that we just saw in the last slide. We take the sine of angle A over side A. We know both of those pieces. Equals the sine of angle B over side B equals the sine of angle C over side C. Now when you do this, you should have what I'm going to refer to as an anchor. The anchor is the piece that you know both values in. And we're going to come back to that anchor twice. So now we choose B or C. It doesn't matter. I'm going to solve for B first. So I'm going to ignore the last fraction in this. All right, we're going to solve a proportion. We cross multiply and divide. B times the sine of 36 degrees equals 8 times the sine of 48 degrees. And then divide both sides by the sine of 36 degrees to get B alone. Now only at this point would I enter anything in my calculator. Notice we're breaking in degrees, so first step is to make sure that my mode says degrees. It does. All right, now I just enter this right-hand side here. 8 times the sine of 48, close the parenthesis, divided by the sine of 36, gives me 10.115. Always round to 3 decimal places. And I'll put that up here in my spot as well. Now I have to go back and find side C. And to find side C, we go back to our original proportion, go back to that anchor. The sine of 36 degrees over 8 is equal to the sine of 97 degrees over C. It's always safer to go back to the anchor because we could have made a mistake when we found B. We could have had a rounded value. Different things like that could throw our answer off. So now we just cross multiply and divide again. C times the sine of 36 degrees equals 8 times the sine of 97 degrees. Divide by the sine of 36 degrees. And we get that C equals 13.509. Now a lot of people, when they have two sides, they say, oh wait, can't I just use Pythagorean theorem? So like once I decided B was 10.115, couldn't I just say 8 squared plus 10.115 squared equals C squared? The answer there is no, because this isn't a right triangle. Pythagorean theorem only works for right triangles. All right, this one is the same type of problem. So we start off, what do we need to figure out? Well, I need to figure out angle A, I need side A, and I need side C. All right, well, angle A is the easy one. We'll just take 180 minus the sum of the two that we know, So 180 minus 102.3 and 28.7 gives us 49 degrees for angle A. And now we set up our big proportion. The sine of angle A over side A equals the sine of angle B over side B equals the sine of angle C over side C. Now we look for our anchor. This time the anchor is our B's because we know both pieces. Choose A or B or A or C to solve for first. I go alphabetically. Let's solve for A. So I have the sine of 49 degrees over A equals the sine of 28.7 degrees over 27.4. Cross multiply, I get A times the sine of 28.7 degrees equals 27.4 times the sine of 49 degrees. Divide by the sine of 28.7. And type it in my calculator. I got 43.061. All right, there's A. Put that in my answer spot. And then we need side C. Always go back to your anchor and set it equal to that piece. So sine of 28.7 degrees over 27.4 equals the sine of 102.3 degrees over C. Cross multiply, C times the sine of 28.7 degrees equals 27.4 times the sine of 102.3. Divide, sorry, you can't see that. Divide by the sine of 28.7. And now we type it in our calculator. Before doing this, I just want to point out, I know that if I get a number smaller than 43, or 27, but so smaller than 43, it's wrong. C is the biggest angle in the triangle, which means it must be across from the biggest side. Always keep that in mind because it's a little check for if you hit the wrong key anywhere. And we get C is 55.747, which is indeed the biggest side. Now there's one more piece to this answer. Notice that my original problem was labeled feet. So we should label side A and side C in feet. All right, this one does not give us a triangle. And there's a good reason to that. So I'm going to draw myself a triangle. And this is the reason why I always say never trust a picture, especially if I drew it. All of my triangles always look the same for these. It's just what happens. So I draw a triangle, label my sides or my angles A, B, and C. Side A is 15, side B is 25, and angle A is 85 degrees. All right, I can't just subtract from 180 to get a missing angle. I can't do Pythagorean theorem to get the missing side because it's not a right triangle. So I have to go straight to my law of sines. Start with sine of A. Sine of 85 degrees over side A equals the sine of angle B over side B, which is 25, equals the sine of angle C over side C, which we don't know either of. Notice that I still have my anchor. My anchor is my A's, but I cannot start by finding anything to do with C. I don't have enough information. I have to find angle B first. So I'm going to ignore that third fraction. And I'm going to cross multiply. 15 times the sine of angle B equals 25 times the sine of 85 degrees. I'm going to divide by 15. 25 times the sine of 85 degrees divided by 15 tells me that the sine of B is about 1.660. All right, well, that's not the answer yet because I want actual B. So to get B, I would do arc sine of 1.660. When you type that in your calculator, you'll notice you get an error because you cannot evaluate arc sine at a number bigger than 1 or less than -1. The answer to this is no triangle. It is impossible to make a triangle with those measurements. Really, what would happen is that this side would be too short and would never end up reaching that third side. So my triangle would not close. All right, now let's try this one. This time, I promise you there's a triangle. So I draw my triangle, which again is going to look the same. Label my angles A, B, and C. Side A is 12, side B is 31. Angle A is 20.5 degrees. All right, can't go straight into any angles, so I set up law of sines. The sine of 20.5 degrees over side A is 12 equals the sine of angle B over side B, which is 31, equals the sine of angle C over side C. Again, we have our anchor. Our anchor is the A's. And I have to start by finding angle B. So I'll take the sine of 20.5 degrees over 12 equals the sine of angle B over 31. Cross multiply 12 times the sine of angle B equals 31 times the sine of 20.5 degrees. Divide by 12. I get that the sine of angle B is about 0.905. So if I'm looking at my calculator, it's 9047 blah, 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 blah. I want to do the inverse sine of that number to get my angle B. Now to be super safe, take your calculator, do second sine to get sine inverse, and then second ANS. Mine is on the negative key. Press enter, 64.783 degrees. Okay, I didn't make myself a little box here, but angle B is 64.783 degrees. I need angle C and I need side C. Now angle C is very easy because I know two of the angles. 180 minus 20.5 minus 64.783 will give me angle C. I get 94.717 degrees. And now I can use my proportion to find side C. Go back to my anchor. The sine of 20.5 degrees over 12 is equal to the sine of 94.717 degrees over C. Cross multiply, C times the sine of 20.5 degrees equals 12 times the sine of 94.717 degrees. Divide by the sine of 20.5 degrees. Oops, sine of 20.5. And let's see, 12 times the sine of 94.717. I got 34.149. Look for labels. They were labeled in meters, so that side is in meters. But the law of sines is kind of funny. Notice that here I was given angle, side, side. If you think back to geometry class, you had a whole bunch of rules for congruence and similarity of triangles. One of the rules that was never valid was angle, side, side. I always remember that. The abbreviation spells a naughty word, which means it's not a valid rule. And the reason for that is because of something called the ambiguous case, which we'll cover in the next lesson. But what if I told you that angle B was actually 115.217 degrees? The sine of that number is about 0.905. So B could have been either of these angles. And if this was the case, then angle C ends up being 44.283 degrees. And then side C ends up being 23.924 meters. So this is called the ambiguous case because we don't know which triangle it is. Angle side side is tricky like that. We'll get into that more though. For now, you do not need to worry about it. Your assignment will be the law of sines.